Students, just as promised, I'm returning to this slide to make it clear how to calculate the float time of an individual activity within a larger network like this. So you may notice the numbers from B here, we're matching those that we did the example float time for before, but we can apply that same logic to each of the activities in this network here. So I'm just going to do this verbally, but activity A here, remember to work out the float time, we look at the far right number, which is 11, the middle number, which is 1, and the far left number of the vertex before A, which is 0. So what we're doing is 11, take 1, take 0. And that's, of course, 10. So that means activity A has a float time of 10. Okay, now activity B, same thing that we did before. 14, take 3 is 11. Take away 1 gives us 10. So the float time of B is also 10 days. Now activity C, we have 15, take 1, take 4. And that also gives us 10. So activity C has a float time of 10. Now it makes sense that activity A, B, and C all share the same float time here because they're on the same path of activities through the network. So what that means is shared between them, there's 10 days of delay possible, but each individual one has a float time of 10. Because when we talk about the float time of an activity, we're considering it in isolation. So we're saying if only this activity is delayed, how much could it be delayed for? But it makes total sense to us that A, B, and C would have to share the same float time of 10 days. Alrighty, activity D and H now, let's have a look. So activity D, its float time would be 13 subtract 2, which is 11, and then subtract 0. So that's still 11. So activity D could be delayed for up to 11 days without delaying the overall project. Let's have a look at activity H now. So we're doing far right number, which is 15, minus the middle number, which is 2, gives us 13, and then subtract the far left number, which is again 2, and that gives us 11. So activity H also has a float time of 11 days and can be delayed for 11 days without delaying the overall finish time of the project. So we've got activity D and H having a float time of 11 as well. And now we can see that activity E and F would have a float time of activity E. 14, take 5 is 9, take 0 is 9. Okay. Activity F, 15, take 1 is 14, take 5 is 9 as well. Okay, so both activity E and activity F have a float time of 9 days. And then finally, activity G here, if we have a look at its far right number, it's 15. And then we have its middle number of 15, and then we have its far left number, which is 0. So we're doing far right minus middle minus far left, and that gives us 15, take 0, which is 0. So we've just found our first critical activity. And so a critical activity is part of the critical path, and it's an activity that cannot be delayed at all. And we can make sense of that in terms of our forward and backward scan as well, because if we remember to the forward scan, the activity G was what created the 15s in this vertex here. So what we were saying when we put that 15 in is that activity G is actually the longest route of activities in terms of duration of time taken before we can start activity I. So what that means is if activity G is delayed at all, then activity I and J and the overall finish time of the project would be delayed. So just to restate that, activity G, 15, take 0, gives us a float time of 0, and therefore activity G cannot be delayed. It is a critical task. Now, activity I and J, they are the final ones that all point towards the finish line. So they will also be critical because they come from activity G here, which is critical, and they are the only remaining activities. But we can just prove that using our calculation as well. So we can do 17, take 2, take 15 for activity I. So far right number minus middle number minus far left number. We get 17, take 2 is 15, take 15 again is 0. So activity I has a float time of 0 and is critical. J will be the same thing. So activity J is 18, take 1, take 17, which is again 0. So what we found here is that activity G, activity I, and activity J all have a float time of 0. Okay. Now that tells us that they are the critical path. So the critical path of activities, well, or I guess we can say the earliest start time, the earliest finish time for the entire project is 18 days, as we know from the 18s here, and the critical path is GIJ. Okay. Just a few more hints here at the end. When a vertex has the same number on the left and right side of it, that implies something critical is happening around it. Okay, it doesn't prove that all of the edges pointing to it are critical. Okay, so coming out of this vertex here, we've got I was critical, we said, it had a float time of 0, and G pointing into it was critical, and that's what the 15 and the 15 is kind of notifying us of. It's notifying us that something pointing into this is critical and something pointing out of it is critical. But it's not guaranteed that everything that touches it is critical, because as we saw, activity C, activity H, and activity F all had float times that weren't 0, and they weren't critical. So the 15 and the 15, or the 17 and the 17, or the 18 and the 18, and even the 0 and the 0 here. Anytime where we have a vertex with the same number on the left and right side, it's just telling us that one critical thing must point into this, and one critical thing must point out of it. Not that everything touching it is critical. Okay, so that's all of 12b and c now. We've drawn these networks in 12a. And now in 12b and c, they ask us to do this forward scan, do this backward scan, do this critical path analysis to reveal basically these two things. One, the earliest finish time for the entire project, which is revealed with the 18 at the end of our forward scan. And then one, the critical path, as well as the float time of activities, which we've just spent some time recognizing how to calculate on this slide and all the previous ones. Alrighty, thank you very much, Year 12. Good luck in preparation for your exam.